Please let me know if my screen is visible. I'm going to share my screen. Please let me know if it is visible. Okay, in today's session, what we are going to see is the recursive query using a common table expression. Okay, so the recursion in the Postgres, the recursion in the sense, it is also known as a hierarchical query. Okay, hierarchical query. So what is mean by this hierarchical query on a CTE is nothing but it is a common table expression. Okay, so on CTE is recursion. So which means it is a type of query which involves the use of this common table expression. Okay, definition in a recursive relationship between the table and the table itself. Okay, between one table and itself. Okay, so the recursion happens within the table itself. Okay, so how to achieve this? It is useful when you need to retrieve the data from the some hierarchical structure. So for example, what I'm going to do is I'm going to create one new table. Okay, so these are all the things which we are going to see in today's session. So I'm going to create one new table. Okay, so what I'm going to do is I'm going to create one new table. Okay, so this is a new table. So this you can see the structure of the table is here I have created one ID and it is a primary key which is serial and the name and their supervisor ID, which means the table itself, within this table itself, it contains their supervisor's ID and the supervisor's name. So which means here I will tell you what is that. See here, this is the supervisor ID. If the supervisor ID is null, then he is at the top of the hierarchy. He doesn't have any ID. Okay. So since this is the serial, okay, since this is the serial, okay, I will try to create the table and then I will show it to you. Okay. I'm going to connect it with our database nm underscore db. That's right. So this is the database and I will try to increase the font size. Okay. So here I have created this table. Okay, already exists. I'm going to drop that relation. Drop table employees, right? So I have dropped and again I'm creating the new table with the supervisor ID. So I will try to insert it. Okay, I'm just trying to insert. So it got inserted. Now what I'm going to do is select so you can see here, this is the stable structure and this is their respective supervisor's ID and this is their own ID. So here you can see here, this is their own ID. 1, 2, 3, 4, 5, 6 is their own ID. So what is John's ID? John's ID is 1. Mary's ID is 2. David's ID is 3. Right? So, and this is their supervisor ID. Their supervisor is also present in the same table. If John is having null values, okay, which means he is the superior. He doesn't have any supervisor, which means he doesn't have any supervisor. Okay, so who's the supervisor for Mary? John is the supervisor because his ID is 1. Okay, this is the supervisor ID. The supervisor ID comes from the employee ID. Okay, so here for David who is the supervisor ID is 2. Who is having the 2 ID? Mary. Okay, similarly for Sarah who is the supervisor? Sarah and Paul. both are having 3 as an ID for the supervisor. Okay. So who is 3? David. Okay. So David is the supervisor for Sarah and Paul. Similarly, for Linda, who is the supervisor? Mary is the supervisor. So this is the structure of the table, and it contains, you can see here, it contains some hierarchical structure. So John is in the first place, right? So this contains some hierarchical structure. In first place, who is in the first place? John, right? So after John. So after John, who is in the next place? So after John, Mary is there, right? So after John, Mary is there. So after who is so for Mary, she's 2, right? So after Mary, who is in the next position? David, right? So who is the supervisor for Sarah and Paul? David, right? And for Linda, Mary is the supervisor. So these are all the hierarchy, right? So hierarchical structure means it's like a tree structure. So it's like a tree structure. So whenever this particular kind of a recursive, okay, this particular kind of a recursive query, which we are going to see in today's session, this recursive query is mainly used when you need to retrieve the data from this kind of, okay, from this kind of a hierarchical structure within the table. Okay, so what I'm going to do is I am going to retrieve. Okay, now what I'm going to do is I'm going to frame some questions related to this. I will just copy paste this one. So for our reference, okay, this is our table output, right? So what we are going to do is, so what is the first question I'm going to form is, so I'm going to frame the first question as I want to retrieve all the employees who is reporting to John or David. Okay, so this is my first question. So what is the first question? So the first question is I need to retrieve all employees who is reporting to David. Okay, so we will take anyone. What is the David's ID? It is 3, right? And we are going to use with the recursive. Okay, with the recursive. So with the recursive, this with recursive syntax is used to define the common table expression. Okay, so by using this with recursive, we are going to do it. So what this with recursive will do, I will tell you shortly. Okay, so we have already seen about the with class, right? In order to separate, in order to give the big query. Okay, if we are having any kind of a big query, so in order to make it as an small part by part for our comfortableness, we have used the with class, right? So similarly with recursive will also do the same, but in the recursive form. Okay, we will see. So I will keep this particular block name as in subordinate. Okay, so the subordinate and as is a keyword. So the same query, okay, the same syntax, but it is the same syntax which we used for with the class, but it is with the recursive. Okay, what this recursive is. So here what I'm going to do, I'm going to select an employee, David. Okay, so in the first block, what I'm going to do, I'm going to select the employee David. Select ID, name. So this is the column name, right? The supervisor ID. Supervisor ID. From where? From what is my table name? Employees. Right? So employees is my table name. for whom I need to find the uh, reporting employee for the David, right? What is his ID? 3. So where ID is 3 is equal to 3, right? So here what I'm going to do is I'm going to do the union operation. Okay, what this union will do is, so for example, if I have used the union, see here, for example, here I am using the union. Okay, so this is consider this is my first table. Okay, so this is my first table output, and consider this is my second table output. Okay, so this is my second table output. So if I am unioning, okay, if I am using this union operation, what it will do is table 1 union table 2, which means what it will do is it will give the output like this. Okay, so it will uh, append all the content, okay, from the first table, from the second table to first table. So this is what the union operation will do. Okay, the similar kind of operation we are going to do here. Why? Because we need to find, okay, we need to find all the employees who are all reporting under David. Okay, we need to find the within the same table we are going to iterate the things. So for that, for during first iteration it will bring the first one, during the second iteration, so like that, within the same table only we are going to do the iterations, we are going to do the select query. So the first query should be union with the second one, second select. Okay, so consider this is the first one, so it should be concatenate with the second one. So we need an output like this. So similarly, in the second query, what I'm going to do is I'm going to select an employee ID, okay, for the same table. Okay, see here, for the same table. So I have already told you about the definition of the recursive, right? So what it will do, it will involves in the use of an recursiveness relationship between the table and itself, right? Within the same table only we are going to perform. So for this employee, I'm going to give an alias name, right? I'm going to give an alias name, and also for all the columns, I'm going to give the alias name. With the alias name only, I'm going to call. So what I'm going to do is I'm going to join this particular table with the same table, right? So as in subordinate. So what it will take, this will take the recursiveness of this table, okay, this particular subordinate. It will take this particular subordinate, and I'm going to give an alias name for this, on what I'm going to join with the supervisor ID, with the supervisor ID of an this subordinate. Okay. So what I'm going to do is on what is the supervisor ID here? Supervisor ID. So supervisor ID for within this employee, within this table. Okay, within this table should be equal to the supervisor ID. Okay, the supervisor ID of the subordinate. So what it will do, it will join once it found the supervisor ID here. Okay, once it found the supervisor ID here, then what it will do, it will check for an employee ID who is having the same supervisor ID. Then it will join. Okay, after fetching this, it will what it will do, it will join with the above query. Okay, so it will join with the above query. So repeatedly, recursively, it will do the same thing. So this part is over. Okay, this particular part is over. So now what I'm going to do is I'm going to do the select operation. So in order to access this query, okay, in order to access this select, so all the structure and everything with respect to the width class we have already seen. Okay, So only thing is this recursive. So recursively, what it will do, it will find until the end of the table. What it will do, the subordinate will find the supervisor ID, which is matching with an ID. Okay. So select e dot I want e dot ID, and I want name of an employee also, and what I want. Otherwise, I will give. Okay, I don't want anything. Otherwise, I will give the star. Okay, select star from subordinate. So this is the with the class name, right? This is the with the class name. So now what I'm going to do is I'm going to show the output to you. How it got retrieved. You can see here under David. So David supervisor ID is there. Okay. So it retrieved where the ID is equal to 3. And what what we got, so you can see here the supervisor ID should match with an ID. See here the supervisor ID to got matched with an, see here after David, the supervisor ID 3 got matched with an David, and also this 3, the Paul, got matched with an David. So these are the two person who is working under the David, which means David is the supervisor for Sarah and Paul. So you need to match it with the David's ID. So in order to do that, what we did the recursiveness. We did the recursive search by using the recursive with the recursive, and we have joined the table with the same table. Okay, we have joined it with the first table, this table, and the same table got matched uh, with an IDs. The supervisor ID should be matched with an employee ID. So that is what we did. Okay, and using the union, what we did using the union, we have concatenated all the, we have appended all the rows which we got using the select query. Okay, so this is what we did. So this is the sample query for the recursive with the recursive. Okay, so we will try to execute the same. You can execute the same thing with respect to the okay, we will try to find the retrieve all the employees who is reporting under John. Okay, so the same thing. What we need to do if we want to find the John's ID, what we need to do, and here I am going to copy paste. So we are going to use the same thing. So ID, supervisor, employee. So here, what is the John's ID? John's ID is who is working under John 1, right? So what is John's ID? John's ID is 1, right? Okay. So the same, I have used the same name, supervisor ID and employees. And using the subordinate, I have matched all the supervisor ID with an employee ID. And we can see here who are all working under John. See here, you can see here. Mary is working under John, and under Mary, David is there. And similarly, under Mary, Linda is there, right? So after that, Sarah and Paul are working under David. Okay, so this is the hierarchy level. Hope you guys understood this. So these are all the points which we can able to achieve the recursiveness inside the same table. Okay, when the table reflects the hierarchical structure. Okay, so we will try to find, okay, in the next question, what we are going to do is we will try to find the retrieve all the employees who have at least one subordinate. Okay, at least one subordinates. Okay. So for this, what we are going to do is, so we are going to use the at least one subordinate, which means we try to use the supervisor ID should be. So here you can see the supervisor ID is repeating, which means it should not, right? We need to find the at least one subordinate means we need to find the distinct one, right? Who are all the person who is having the distinct supervisor ID. So in order to do that, what we need to do is, I will take the same one. I'll take the same one. For example, manager, like that, we will try to do it. So here for the supervisor ID, what I want is I want to find the distinct value. Okay. So for this distinct value from the employee, okay, the supervisor ID should not be null also, right? So I don't want the supervisors who is having null. So for that, what I'm going to do is the supervisor ID should not be null, where supervisor ID is not null. Okay, not null. So this is what I'm going to do. So from this, what we used to retrieve, we can retrieve the distinct value of the supervisor ID and whose supervisor ID is not null. This is the first thing we will retrieve from the this particular block of the select query. Okay, now I'm going to do the union operation with the query. Okay, with the query whose this particular manager's ID. Okay, this particular ID should be. So I'm going to join it with the same table, and the supervisor ID of this, okay, of this who is having not null values, we have retrieved in the first block. So now what we are going to do is we are going to retrieve the person who is who are all having at least one subordinate. So which means I need to match it with the supervisor ID who is whose ID is matching with an employee ID, right? So here from the employees, let it be. Now I'm going to join with the manager. Manager is nothing but this recursive function, right? So here I'm going to do it with the manager em. So for this, what I'm going to do is I'm going to join the e.id, which should be matched with an m.supervisor. So what is the m dot supervisor? So m supervisor is nothing but an after retrieving the each and every time I'm going to retrieve one ID, right? And also the first thing which this particular code will execute is this block. So from this block, it is I have retrieved all the not null values, right? All the not null values with respect to the supervisor ID. And what it will do is recursively it will call. Okay, recursively it will call, and what it will do is it will try to fetch the IDs from the supervisor IDs, which are all matching with an employee ID. So for each and every call, we are going to do the union operation. Okay, so this is what we are going to do. So select star from manager. Okay, so who are all the manager who is having at least one subordinate. So 3 is the manager who is having who is 3 David, right? And who is 2? 2 is Mary, right? And who is 1? 1 is John. So it is in the it is a retrieve. It has retrieved in the descending order, right? So first it retrieved the manager ID for the David, and who is having only one subordinate, and similarly for who is two is Mary, and also for John. Okay, John is having Mary and Mary is having David. These three person are having only one supervisor. Okay, so these are all the persons who is having one supervisor, one subordinate. Okay, so the query which start from the top of the hierarchy John and retrieves all the employees who is reporting to him. Okay, so this is what who is having. So here we have retrieved from the John point of view, because John is having not null, right? So the supervisor, he doesn't have the supervisor ID, right? So here the recursive select for the select all is for the manager who are all having at least one subordinate is our aim, right? So the initial query will select all the subordinates, and it will retrieve all the employees who is matching with the supervisor ID, and using the union operation we have completed appending. So this is what we did. Okay. One more query we will try to do it. So excuse me. So we are going to retrieve all the hierarchy of an supervisor for an given employee. Okay. So hierarchy level is nothing but, okay, we will try to do it for all the recursive select for the supervisor up to the top of the hierarchy, along with the all the subordinates. Okay. So for this, what we are going to do is the same thing we are going to give for the Linda. Okay, for Linda. So who is Linda? You can see here. So Linda is having 6, right? Employee ID as in 6. So what we are going to do is, so I'm going to uh, retrieve all the hierarchy. Okay, all the hierarchy of an employee with an all level. Okay, so I need everything. I need everything from here. So I will try to copy paste it. And from the level of 1. So for that, what I need to do is 1 as level. From the first level, I need. Okay, from the first level to from the particular employees level. Let us keep it as an let us keep the ID as an 5. Okay, where ID is equal to 5. So up to 5th level. What is my aim? From the level 1 to up to 5th level, I need to retrieve all the hierarchy of the supervisor for the given employee. Okay. So from 5th level, so from this level, okay, from the 5th level, what is the hierarchy? So 5 is who is nothing but a Paul. Okay. From this level, who is the hierarchy? Okay, for this Paul, who is supervisor? David. For David, who is supervisor? Mary, John. So like that, for the given employee, I need to retrieve. Okay. So what we are going to do is from this level, from the 5th level. Okay. So union. I'm going to do the union, and here for the same thing, we are going to do it. We are going to match it with an employee of an hierarchy. So I'm going to join it with the same table. Okay. So after joining with the same table, you can see here, after joining with the same table, so what I'm going to do is, so I'm going to retrieve all the level of an employee up to 5. Okay. Up to 5. So with a specific order, I want to display it. Okay, with the specific order and the level I want to display. So for that, what I need is I will take all the employee name and everything. Okay, I will take all the employee name, employee ID, employee name, and his supervisor ID, and in what level he is in. H dot level. So with respect to that particular level plus one. Okay. So by incrementing this level plus one, I can able to do the next level of the hierarchy. And who is in the next level? Who is in the next level like that? It will goes on. Okay. It will goes on for an each and every hierarchy. So select start from hierarchy. I will take this hierarchy. Okay. So I'm going to order this by using the level. Okay. Then only we come to know who is in the next level like that. Okay. So level wise, I'm going to do the ordering level in a descending order. Okay. Descending or ascending, anything is okay. You can see here what is the syntax error. Okay, I have missed one comma, I think. You can see this is the level of an employee. Okay, he is in the top level, right? And he doesn't have any supervisor ID. So who is in the next level? Mary, right? Who she's in the next level. She's in the next top level. After 4, 3, 2, 1 like that, I'm keep on decreasing. Okay. So John is in the top level and he is at the top level 4. So Mary is in the next level. Similarly, David is in the next level and under his under David, the ball is working. So this is the up to Paul only we have retrieved. Hope you guys remember this. Right? Up to Paul only. Who is at the, see here, Paul is in the ID 5. So up to 5 only we retrieve. Right? Up to 5 only we have retrieved. Right? So this is the level. If you want to do it in the level like this, you can do it. So who is in the first level, who is in the second level like that, you can do it. I just took it as an okay. Let it be the plus one because we are getting the minus values since it is subtracting it within next level, right? So this is the level of an employee. So here what we have did. So we will try to copy this and paste it here. Okay. So for each and every employee, we have certain level. So under this employee who is working, under this employee who is working up to the level, up to the fifth one. Okay, up to the fifth one means whose ID is fifth. So we have retrieved who are all the supervisors above this Paul. So David is his supervisor, and above David, Mary is his supervisor, and above Mary, John is her supervisor. So like that, who are all the supervisor, who are all the hierarchy level he is having. Okay, which means the Paul need to report to David and for Mary and John. So these are all the three person Paul need to report. So David need to report to Mary and John, and Mary need to report to John. So this is the hierarchical level. So we have already seen if a table consists of any kind of a hierarchy level like this. Okay. So any kind of a tree structure or a graph-like structure or hierarchical structure like this using the common table expression definition. It defines a recursive relationship between the table and itself, which means within the table itself we can able to do this kind of a recursive operation in order to find the level by level of an a level by level of an things. Okay, level by level. Here we have find the level by level of an employees. So this is what we have seen in today's session. So please try to execute this kind of a query. This is very important. This recursive is very important. Please try to practice. Okay. So now I am stopped sharing. I will stop